Good afternoon, evening, morning, everyone. Thank you for coming along today. Chris and I are talking about developer velocity and why you should care about it. So our goal today is to help equip you with the concept and then help you understand why it's of value and how you can sell it to your bosses to help give you some of the important things that make a techie's life more bearable and more fun and stimulating. We will be sharing a version of this slide deck as a PDF into the comments of the meeting, just titled Developer Velocity. So whilst I put the slant on it today of enabling you to have the discussion and kind of focus on things that are important, you'll have the slide deck to go and talk to your manager and says, Microsoft recommends this. So hopefully it'll be of use to you. Today we have Chris, who will be joining us a little bit later on in the deck, and myself, Steph. We're both really passionate about technology and the technology communities. We've got a number of links that you can check out for where we have our technical contributions, where we share resources. So please do consider connecting with us online. We love to be asked questions and to see what matters most to other techies inside the tech community. So as I said today, we're going to talk about what developer velocity is, outline some of the problems that we face, kind of a structural piece around being IT folks in businesses. We're going to look at some of the areas that you can improve and why you should. Chris is then going to take us through how Microsoft has been on our developer velocity journey with a really big focus on DevOps. And then we're going to look at some of the different actions that you can be taking that make it easy for your business to start getting more value out of tech and the work and the hard work that you do every day. So the big problem, right? Lots of the executives in annual reports are saying that they want to digitally transform. And it's been particularly accelerated and challenged because of COVID, because a lot more businesses have had to be online savvy. And it's been really tough, but it has been very productive for a lot of businesses. When you're talking to your boss about why developer velocity comes in, it's because of stats like 70% of digital transformation projects don't hit the level that they're after. And that's a bit better than the old 80% of IT projects fail. So we're at least maybe getting a bit better at delivering tech to have value, but it is still a big challenge. There's only 20 million software engineers in the world, which really is insufficient to meet our business needs. If you're a senior engineer, you might be partly involved with hiring, or you might be an IT manager. Trying to find great people to work at your company is super hard. It's really difficult to find staff, which makes it really difficult to deliver great tech. So when we're thinking about things like developer velocity, it's about how can we ensure that every software engineer, every data engineer, every data scientist, every technologist in our business can be delivering as much value as possible without us just going, hey, work 60 hours a week and grind your fingers to the bone, typing thousands and thousands of lines of code. So we need a sustainable, scalable way to overcome the fact that we simply do not have enough people to get everything done. And this is where developer velocity comes in. So developer velocity is an overarching concept about how we start delivering business value through technology. And there's a couple of three key areas around that. One is being able to collaborate, to be able to deliver tech efficiently in the business, and most critically today, delivering it securely. Helping us be able to build software productively so we don't spend unnecessary time on getting things into production. And then the final piece is how do we scale it? How do we ensure that everybody is able to build productively, that we're building the right things. So developer velocity is a big overarching concept about delivering business value more quickly through tech. So things like DevOps, MLOps, DataOps, all the things ops sit underneath developer velocity. And you'll see why they're a subset of developer velocity as we go up. So the too long didn't read of the research that Microsoft and McKinsey did on developer velocity is if you want your business to get the most value out of tech, you need to invest in tooling for your team. So no quibbling over things like Redgate SQL licenses for a couple £100. That just is not meaningful. Supporting project management and building cross-functional teams. Fostering a culture of innovation and continuous learning. And talent management. How do you get the right behaviors and kind of attributes of your tech team? How do you make sure your tech team can be working sustainably? And how do you retain staff when the average techie moves every 2 to 3 years? Those are the big ticket items. If you're doing all of those right, then the next thing is for you. Working with open source is how you get that next step forward. So open source is good for everyone, but particularly if your business is already great at delivering value through tech, open source is where you should be investing that next level of time. For people who are not tech-focused businesses, where they're not like a legal tech business, but they're a legal firm, they're a professional services firm type of situation, moving to the cloud is a really great way of improving things because those businesses typically have undersized IT departments. They're all trying to get so much done. They often have difficulties maintaining all the compliance and security pieces, getting all the patching out, managing things like the BYOD, building software that, meets CRM, ERP needs, trying to do all the business process pieces. So in a business that is primarily not a tech business, moving into the cloud, using SaaS software as a service products, using platform as a service, these kind of things can help cut a lot of the burden for the IT teams to help them move faster, more safely. An increasing area of value as well is actually getting a lot of work done outside the IT team. We've all sat there looking at a product, a ticket backlog in the old days of lots of requests, absolutely not enough time to do the business as usual, to be able to get the little projects done that help the different departments, because we're all working on the big projects, the big things that help the strategy. But actually, everybody in the business needs to be productive and needs to be able to scale. So if we can help more people in the business be able to deliver business improvement through technology, then we can actually move faster as a bigger business. And then there's some kind of new emerging capabilities that can start helping you if you're doing all of the above. So you can be using machine learning to detect failures in your code. You can be automating different bits and pieces. Observability is a really critical area. So there's a lot of additional stuff that you can be doing to take the quality to the next level. So this is one of those key slides to give management, and you can basically draw a circle around the bit that is most relevant to your business. And then to sell it. So the person to sell these types of activities to is obviously your boss, because your boss is the one who's going to give you some of the time, but also the chief financial officer. You want the people who own the money in the business to be on your side. So spending time to improve how tech gets delivered into the business leads to higher revenue growth. So there's a really big difference between the people who are really slow, who might be taking 6 weeks to add a column to a report, or to be able to, have an app that's 20 years old and they're afraid to touch it, through to the businesses that have spent a lot of time getting DevOps and site reliability processes working, who have product management and are doing open source work. Those businesses who are at that level make way more cash, and they grow their market faster because they can be more agile at delivering what customers want. So when you're talking to the CFO, say spending on developer tools will help us make more money. When you're talking to the CFO or the chief operating officer or the CEO or the senior people in the business, if you're in a non-software company and everything's in an on-premises situation, that's when you want to be pointing out that you can get more business impact from tech if you start moving to the cloud. I don't mean move everything to the cloud, but strategically moving things to the cloud that can be secured more easily and can be strategic for business processes and things like that is really critical. You can also scale size and things potentially more than an over-constrained local data center by moving stuff into the cloud and giving more room for those core processes. So again, you can message this to the IT manager and above around what gets moved to the cloud for business impact. This is one of the best business cases that you can get for tools. If your IT team has lots of tools to help them do the job, on average, people will stay 50% longer than they would have otherwise. And it's because they know they have support, they know that they're not doing lots of manual grunt work, and they know that they're focusing in on quality and delivering value. So if you've been struggling to get sign off for a tool or or a Visual Studio subscription or something like that, or some training to go with it, 47% increased retention rates is the key thing to be pushing, because what hiring manager wants to go through a painful recruitment process? If you're looking at things like Power Apps and the Power Platform or other low-code, no-code options to help more people in the business to get stuff done, then you can be talking about how this makes your business more innovative. You get new solutions from it, different areas. So that can be a way to message Power Platform types of situations, and really just getting more people to do the smaller projects in the organization. So as a technologist, you can focus on the really big ticket items. And then if you're doing a lot of it, so your business might be, you might have a really great tech team, you're delivering well, you're in the cloud, you've got your compliance and your security processes all nicely integrated into your CI/CD. Maybe your manager is a little bit concerned about the benefit of open source. Working with open source increases staff retention rates and again increases innovation and business value. So there's a lot of benefit to starting to invest in contributing some of your code as open source and using open source more transparently and kind of sponsoring those projects. So that's it for kind of the facts that I wanted to arm you with for helping you find the problems or areas where your business could be better, and have the facts to go talk to those managers about getting the things that you think are necessary. And depending on where you are in the process, there's some critical steps. Not all of these are things that you can enact, but they are things that you need to enact either individually or as a business. So totally invest in tools. If your business is stingy about tools, that's one of the first steps. You need to start thinking about product focus. So even if you're if you work on purely internal IT delivery, how are you delivering products that are useful and adopted by the business? So restructuring things instead of silos by function, but instead by capability, that helps give you a more value-oriented delivery capacity. People need to be able to fail, and people need time to experiment. Otherwise, we foster the definition of insanity, where people keep doing the same thing again and again and expecting different results. And then the talent management. How do you hire and retain and reward people for having a high impact on having a lot of value into the business? If you're doing a lot of those things, that's when you can be focusing on getting into the cloud, looking at low code, no code solutions, and adopting open source. Those things help you go much faster. And then you can be looking into the future and starting to think about your cutting edge capability. And that's where you start thinking about things like AI code writing or unit testing or observability and ML to try and predict when you're going to have problems with your site. So there's a roadmap and a set of actions which doesn't look too unachievable for a business, that again, as a slide, you can be showing leaders to say, this is where we are, these are the steps we need to be doing. So you can message upwards and be able to have nice, simple actions that people recommend. So developer tools, as we said, higher retention and satisfaction, product management, psychological safety and talent, open source, cloud adoption, citizen developers, and then get really cool with some funky emerging technology capabilities. So hopefully I've armed you with a lot of the business case that you can take and concrete actions that you can take to your manager, your manager's manager, and your CFO. And because storytelling is so compelling, people really learn from stories as well as some people learning from stats. I'm now going to hand over to Chris, and Chris is going to take you through the Microsoft journey for how we got better and improved our developer velocity. Over to you, Chris.
Okay, thank you, Steph. So I'm going to be talking all about Microsoft's journey, transforming both from a DevOps perspective and how Microsoft focused from a developer velocity perspective as well. And before we jump in, I just want to start with a definition of what is DevOps. Because if you survey 100 people, what is DevOps, you probably get 100 different definitions. And the Microsoft definition is this on screen. DevOps is the union of people, processes, and technologies to deliver continuous value to users. Now, we've heard about people, process, and technology before. If you think about ITIL, for any of you in the service management space, people, process, technology is there. But the really important part of this definition for me is those last few words, to deliver continuous value to users. Now, as an example, a lot of people think about automation as a part of DevOps, and I could absolutely automate every single part of my system, every single deployment, every single test. But if I'm doing that for the sake of doing it, what is the point? If I'm working on automation that never sees the light of day, that never positively impacts my users, from a developer velocity perspective, I've wasted a ton of time on something which ultimately isn't driving that business value, isn't making the experience of my users better. So ultimately, those last few words of the definition are probably the most important overall. Now, these are a few of the different pillars that Microsoft really thinks about when we think about building these apps of the future. The first is about adopting a growth mindset. Now, Steph said something really interesting there about fostering that culture of psychological safety. Adopting a growth mindset is a really important part of that. Think of those times where maybe you want to go and ask a question, but you feel you can't ask it because someone who's that know-it-all is going to come back, for example, and make you feel insignificant almost. That's not an environment that we want to be a part of. We want to be a part of where failure is okay. Things absolutely go wrong. We don't always get things right. But the important bit is learning about that. It's not a blame culture. It's a learn-it-all culture. This thing has happened. How do we grow from that? How do we stand up from that? And how do we move on and factor that into how we move forwards? Customer obsession, again, a huge part of this app of the future concept from Microsoft and DevOps and how that links in. Because again, think of that definition: people, process, technology to continuously deliver value to our end users. So we need to be thinking about those users all the time. We need to have that obsession. What parts of the application are they using right now? What parts are they not using? If our development efforts is focusing on the parts that they're not using, then are we really being customer obsessed? Are we really focusing on all of those signals that our customers are giving us? Are we seeing a rise in support tickets, for example, from internal users? Are we seeing a load of tweets, for example, from our external users? Or are our ratings in the App Store falling because we've pushed out some really bad quality applications recently? Being obsessed about those details and prioritizing those aspects is super important to make sure that as developers, we're focusing not only on problems, but on the right problems to fix. And speaking about the right problems, think about a company the scale of Microsoft. Think about the organizations and the brands that you're aware of. Office, Windows, Azure, Xbox, Dynamics, DevOps, so many more. There's many different brands within Microsoft that are their own unique businesses. But of course, Microsoft as a company has an overall direction that it's going in. And making sure that all of those teams and all of those organizations are aligned on shared objectives. And even those organizations, Windows or Azure as an example, are two huge organizations inside of Microsoft. So it's really important to make sure across all of those teams, there's harmony. There's a shared understanding of what that overall goal is, what good looks like, where you're heading to, so that then that can distill through the teams and everyone can understand where they're going. So to give you a bit of context here before we start really going deep on some of these concepts, these numbers are from about 3 years ago and are taken from Microsoft's internal engineering systems. So at the time, Microsoft was using, or rather, Microsoft had 105,000 engineers using their DevOps platform internally. That equated to 4.4 million builds a month, 5 million work items which were viewed per day, 2 million Git commits per month, 500 million test executions per day. Now, I don't know about you, but I would not be able to run 500 million tests in a day. And then 500,000 work items updated per day, 85,000 deployments per day. So when we think of velocity, think of those numbers, an organization the scale of Microsoft, some of those brands and products that you're aware of. These are some of the numbers that Microsoft was running at 3 years ago. Now, of course, there's been many different acquisitions since then. There's been new products, people recruited into the company. I can imagine those numbers are only higher and continue to grow. And this is why I want to tell you the story about Microsoft, because you can see this as some significant scale here that we're talking about. So the first part then is measuring the right things, measuring what matters, as the picture says on the right-hand side. Now, there's a concept which has been around for a little while, but is certainly growing momentum in the industry. And this is this idea of objectives and key results. And this is a way that we can create this clarity, and we can make sure that there's this shared understanding throughout our organization. Objectives and key results is effectively a way of communicating what that strategy is throughout the organization. So your objective is your vision. So as an example, grow a strong and happy customer base. That is a vision. that is a statement. But your key results then are something measurable as a result of that. So we want to increase our external net promoter score from 21 to 35. We want to increase the satisfaction on our documentation from 55 to 65, for example. Now, Microsoft's engineering teams all operate using this model. So the OKRs are set from the kind of the highest level, and then each team will then be responsible for setting their own OKRs to align to that overall goal. So growing a strong and happy customer base might be an all at Microsoft goal, but then the Azure team might have their own way of focusing on that, whereas the Windows team might do something slightly different. They're still overall working to that same vision, but they then have the autonomy and the empowerment to go and approach that in their own way. Now, the thing is about these key results is if you turn every single one of the key results green, a lot of people will say you probably haven't done that right because you haven't been ambitious enough. Because one of the main drivers behind objectives and key results is this idea that you can go ahead and turn something around. This book on the right-hand side that's referenced on screen here is a really great read. I've personally read it. I recommend it. And it talks about several companies that have been competing in the market and used these objectives and key results to bring the team together, to rally around a common cause and get some momentum behind an idea. So you want to be ambitious with those key results. The way Microsoft does them, they're measured on a per quarter basis. And the best key results are typically leading indicators because then you're planning for the future. You're generating that clarity for the future. So objectives and key results have been a key part of creating that clarity across the organization and the various engineering teams within Microsoft. But that then takes us to another thought or another question. What do we actually need to measure? What are the important things when we think about key results? I've seen lots of different things along the way of various organizations that I've worked with. Some looking at things like lines of code, for example, which I never think is a good metric to go and look at because I can write many lines of code. I can't promise they'll be any good, but I can definitely write tons of code for you. But it really comes back to that idea in the beginning from a DevOps perspective. People process technology for the delivery of value to our end users. So how do we know if we're being successful? Well, we need to understand what our customers are doing. So are we gaining customers? Are we acquiring new customers, for example? Are we able to retain those customers? Are we keeping them on the platform? Or are we getting them onto the platform and then we're losing them because actually our marketing did a great job, but actually the product isn't as good? Are we engaging them? Are we making sure they're satisfied, for example, and tracking those satisfaction scores, whether that is through things like Twitter or social media or within the application, for example? And ultimately, tracking feature usage, building telemetry into those applications, so then we can understand actually, are our users now using this service since the recent release that we pushed out? Has the usage gone up? Has the usage gone down? Because if the usage has gone down, maybe we made a bad choice. Maybe we shouldn't have updated that user interface for the payment of our retail system. You know what? We made a bad choice. Let's actually roll that back because users hate that new experience. And that's where this growth mindset comes in and being really data-driven and data-led in this idea. And that's okay. We're still thinking of the velocity from our developers' perspective because we're grounded in what our customers want and the insights from our customers there as well. Pipeline throughput. Now, we mentioned a bit earlier around automating all the things. Of course, you can absolutely automate everything, but there comes a point where there's diminishing returns. So really what you want to think about here is how efficient is that overall DevOps process? How long does it take to build? How long does it take to test? I'll give a particular example a little bit later around the Azure DevOps team on that. But things like deployment times, how long it takes you to respond to, mean time between failures, these kind of things. How long does it take for those responses? Those are all very concrete measurements you can focus on and improve upon to make that experience better. Because again, from a velocity perspective, if you need to react to a change, if you need to push something out really quickly, or you want to react to some user feedback, the tighter you can make that loop, the more efficient you can be, and the quicker you're going to be able to delight and please your users. And of course, fundamentally, as users of all of these systems, whether it's applications, whether it's our favorite retailer, whether it's our cloud platform, or whatever system you want to think about here, we don't like it when things go wrong. None of us like it. Whether you are the person who wrote the code, whether you're the operator of the system, whether you're a consumer trying to buy your favorite product and you've got that in the shopping cart as the site goes down. None of us like live site issues. So again, that growth mindset mentioned earlier, not placing blame, but being very methodical around understanding what has gone wrong. How did that go wrong? Why did it go wrong? In a blameless way, and being able to take those insights and learn from those and factor those in to the future. So time to detect, time to communicate, and time to mitigate are all critical aspects of that. You'll notice whenever there is anything degrading from a service perspective with Office 365 or Azure or those cloud services, there are always those communications which go out. Customer impact and support metrics, those are the things you can then start tracking. Because if you can see that you're regularly seeing some service degradation or some service challenges as a result, that clearly is an investment area because your users are going to be frustrated with that. That's something that you need to prioritize and focus on. Aging lifecycle problems and SLAs per customers. Ultimately, are you meeting customers' expectations? This is what this entire slide is talking about. We're not talking about number of work items completed. We're not talking about burn down rates or anything like that. All of these metrics and the way that a lot of our engineering teams now think is purely in terms of customers and how engaged they are, their satisfaction with the product, and all of these metrics which ultimately track back to customer satisfaction. And again, this slide really reiterates that, being customer obsessed. So some of those particular examples, telemetry is a really core part of being able to understand how your users are interacting with your system, examining a hypothesis. So if we change this button from blue to red, we should get some increased user engagement. When actually maybe red signifies the delete button and users steer away from that. So telemetry is a great way of being able to experiment with changes and understand how your users react to that in the real world. But ultimately, that means we need to make these incremental changes. We can absolutely be data-driven, but we need to make small changes often. And these goals are always questions. What happens if we change this part of the user interface? Do we increase? Do we decrease? Do we get an increased amount of engagement? This is all very experimental, and this is where this idea comes together of developer velocity and DevOps, is being able to start experimenting in that environment. Now, a big part of Microsoft's transformation here is about how the various engineering teams have actually evolved over time. So if I just step the slide back here for a moment, what you'll see is originally teams were broken out into various disciplines. And I'll do that once again, just to make sure you all see that. So we had developers, we had testers, and we had program managers. And it works, it's functional. It's the way a lot of organizations have been structured, are structured. But the challenge here is you're very discipline focused. I come in as a developer and I want to develop the best code that I can possibly develop. I'm going to come in as a tester and I'm going to test that thing and I'm going to test it really well. Or I'm going to be that program manager and I'm really going to focus on overall scoping and designing that product. But we need to start breaking down those silos. So the first step was bringing developers and testers together into a central engineering function. So we have this central engineering function, and maybe central is the wrong word there, but a unified engineering function, let's say. But then we still had program managers, and we still had ops and SRE as well. So what we then did is we brought all of those together and distributed them into feature teams. And the beauty of that is you now go into a world where, as a team, you're no longer focused on your discipline. Your discipline is part of what you contribute, but what you truly and deeply care about is the feature that you are working on. So there'll be a feature team, for example, for, I don't know, Azure boards, for example, or Azure repos, or whichever Azure service you want to go and pick. There'll probably be a feature within that service. There'll be a feature team that every day that is the thing that they focus about day in and day out. The beauty of that is then you start thinking like a customer. You're not thinking about, I'm going to develop this thing, I'm going to test this thing, but you start thinking about the end-to-end satisfaction and the end-to-end usage of that particular feature and that particular product. And what that means is, as a team overall, you own that service end-to-end. So this is where things like site reliability engineering come in, because if it breaks, guess what? You're the team who are now on call for that. So there is that real reason to go ahead and make sure that actually what you're pushing out is quality, and making sure that actually what you're doing is in the best interests of the users. But we're not done. We're far from done. There's so much more as a company that Microsoft can do. And like most organizations, we will continue to go along that journey for, I'm sure, a long time. But there's still more things as an organization that Microsoft can do. And some of the things to get you thinking here, just as a bit of a jumping in here.
So far, we've given you what developer velocity is, the business case to sell it into the leadership, and provide you with the story of Microsoft's own movement towards restructuring both how it thinks about technology value and how it aligns everything right down to the job titles and how people work inside Microsoft to deliver better velocity from a developer perspective. So now wanted to kind of spend some time, a little bit of time on the concrete actions that you can take. So this isn't just a fuzzy concept like, hey, I learned a new buzzword today, but more, let's make this practical and applicable. So the first thing is, where do you want to find out, where can you find out more from? So on azure.com developer velocity, there's a landing page with lots of information and insights. So that's a great link for you to go through. And there's also a developer velocity assessment, because we all love a quiz and we all love to know how we're doing. You can do the developer velocity assessment and get kind of a developer velocity speed for your business. You know, if you need that extra credibility with your boss, you can fill it in realistically and say, Microsoft and McKinsey says we can do better. Let's go do better. Those are the primary resources that we can go to. So next up, Chris is going to tell you about improving your collaboration.
Indeed, this whole collaboration aspect, you can imagine, is a huge part of making sure you're sustainable in that developer velocity journey. If you think to your own organization, how often are you able to go and work with another team, maybe a center of excellence, a shared service team, someone you don't work with in your immediate team on a daily basis? Are you able to actually go and read their code? Are you able to go and commit to that code base? Are you able to collaborate with them on that code? All of these aspects are really important and very, very common practices in the open source space. Thinking about opening pull requests, for example, to your favorite open source projects is absolutely a common task that you would go and do. Why can't you do the same thing within a source? This idea that actually inside our organization, I could contribute to that central repository. I could contribute to that code base because I know that's a problem for my application. But actually, you know what? Rather than raising a ticket and waiting for a month, 2 months, however long it takes for them to review and get back to that, maybe I can propose the fix as a pull request, and then they can go ahead, review that and accept that or request some changes. So ultimately then, rather than continuing to work in silo, we're starting to work on this very open model, but inside our organization. So what that means then is we have these smaller teams which make these overall final decisions then, and we can start bringing this agility into the organization. Now, this is the story that I mentioned earlier that I really wanted to reflect on. Driving towards automation. This story on the left-hand side is where Azure DevOps was quite a few years ago now, back when it was Visual Studio Team Services and shaping to become a software as a service. So for anyone who doesn't know the history, Azure DevOps, previously Visual Studio Team Services, used to be an on-premises project called Team Foundation Server. It's now known as Azure DevOps Server. You can still deploy that on-premises today. But the challenge back then is it was a boxed product. So it was something that was released every 2 to 3 years. The way that the test suite was designed back at the time was very much focused on integration tests. Now, for any of you who have written your integration test suites, you will know they are not quick tests to go and run. They are tests which can take minutes, maybe hours, maybe even longer, depending on how many integration tests you've got and how much kind of setup and tear down you need to do in between all of those tests. That was the exact problem that the Team Foundation Server or Azure DevOps team had back at the time. They had a suite of tests which were very focused on integration testing. And over time, what you can see on this graph is they gradually grew the number of unit tests that they had in their overall test base. And what that meant is they actually went down from a test suite which took them days, and there is a link that I can share as well to this case study. I'll make sure it goes into the chat. Where it took them days to actually go and get answers to those tests, to now minutes or hours. And this is the difference here, is the fact that actually they're now releasing a service, a live service, every 2 to 3 weeks. They are pushing updates out on that. If they had to rely on those integration tests, which take 24 hours plus, that is going to completely hamper any developer productivity. So you're no longer going to be productive. That velocity is going to be hindered as a result of that. So this is a really great example of a team that took that developer velocity concept, identified a problem in their current operating model, and turned that around to go and fix that. So tests are one part of that. We've talked about inner sourcing and this idea of being able to use pull requests. Really important concept from a DevOps perspective. Being able to have some part of our code base which is production ready, being able to make sure that we can go ahead and push those changes out at any point if we need. But to do that, to make that very controlled environment, we need a way to be able to control the changes that go into that code base. And the way that we do that across Microsoft is by utilizing pull requests, controlling those changes, gating those changes before they can go in. So maybe there's a peer review, for example. Maybe there are some automated tests. Maybe we have to have a build run or some unit tests run, or some external code quality checks have to happen to make sure that that code is allowed to be merged, that code is good and safe.
So the next kind of key action that you can think that you should be considering applying is how you secure your software. One of the absolutely biggest drags to developer velocity is people worrying that code, database changes are not safe to release into production. So there's three areas where people have that fear about code and changes. One is equality. Is it going to break stuff? So things like the pull requests, the high level of test automation, things like that address it. And then the other two are compliance and security. How am I going to know that this meets our regulator requirements, our legal requirements, and how do we know it's safe for people to use? Embedding the compliance and security practices from onerous, long, time-consuming manual processes and bringing it right into your collaboration on your code base is really critical to improving trust and being able to move faster. So some of the things that you can look at include baking in the policies that people need to adhere to inside your CI/CD or your Microsoft 365, anywhere that you can apply policies and controls in your Azure environments, inside your, things are being deployed into your data center, things like SCOM, having those policies set up and just like they're always running is much better than having a security team who has to manually apply these things. We should also be looking at things like vulnerability scanning. Can we be checking our code base from a security perspective? We have the capabilities in things like GitHub to be running it to look at dependencies in things like our front-end applications to find risky packages and things that are in use. So we can automate all of that. And that just is really great for helping add this concept of trust to help us improve our speed. And we can put those into our CI/CD. So every time we build something, we run a check. And the important thing about all of these is that it really helps us improve our stance on security. And we can take it further to help introduce like the concept of zero trust, where we make sure that the developer who submits a commit is the developer through things like multi-factor authentication or commit signing. When we think of security as a core platform capability and things to integrate into our collaboration on software and data and everything else that we do where we write code or we have technology, including infrastructure, the more that we embed security into standardized practices and stop it being a manual intervention check, the faster, the better our developer velocity can be. So those are the high level steps. And we've also brought on the next slide what that might look like through the different steps of kind of doing some code.
Absolutely. I think the key point to reiterate here is the fact that security isn't this bolt-on that sometimes people think that it is, and it hampers the project. Actually, security is something that you do all the way through, from your threat modeling to your pre-commit and commit stages, all the way through to some of those great concepts Steph just mentioned there.
Yeah, I heard a great metaphor for security. Doing the automation stuff, security acts like brakes in your car. Yes, brakes slow you down, but actually, because you have the capability to slow down really quickly when you need to, you can actually drive faster. You're not having to drive in a continual state of hyper awareness, being worried about who's going to hit you, because you can go faster, and when you need to, you can slow down safely. So those brakes on the car, that security automation, really just enables you to go faster overall. So Chris, tell us about the CI/CD journey and security practices that folks can put into their system.
Super, thanks, Steph. Yeah, it's absolutely doesn't just start at CI/CD. It's something all the way through. So starting all the way from even before you commit to the project, and in those design stages, starting at things like threat modeling, making sure you've got your coding standards in place, and making sure you're, from the very beginning, peer reviewing. And then from there, when you start writing your code, you can adopt tools like static code analyzers. There's many different organizations out there. I'm sure we all have our favorite software that we use for that on a day-to-day basis. But we can then start integrating at that stage unit tests, and not just unit tests from a functional perspective, but security unit tests. So what happens if I pass in or try to pass in, for example, a SQL string into this workflow here? Does that get caught? Does that pass all the way through down to my storage layer or to the next layer? What happens there? Dependency management. When we think about some of the attacks that we're hearing of in the news these days, making sure that dependency management is something top of mind is so critical, because if it's in our software, it's something that we need to worry about. And it's almost like that idea of the Trojan horse, from that kind of concept of letting the horse into the gates there. That really is dependency management. If we don't understand what is in those packages that we're using in our code base, then frankly, how do we know that there's not something bad going on in there? So you really need to understand what's happening there. And there are tools that can help you with that. There's plenty of great tools out on GitHub, for example. There's many great tools out there as well from other vendors. But then from the CD perspective, from the deployment or continuous delivery, things like infrastructure as code, being able to have that immutable infrastructure, destroy it, create it, destroy it, create it, destroy it, means that we're no longer having to manage those long-living environments with certificates that may be outdated or long-lived, maybe the passwords that haven't been rotated, for example. And overall, being able to have this very dynamic environment, which is strengthened because of the dynamic nature that it has. Ultimately, deploying security scanning. So if you think of various platforms, maybe you'll do some runtime scanning, for example, very common in the container space. That's something that you may then want to consider as part of the release out. How do you go ahead and check for those vulnerabilities before you serve it to your end users? And then, of course, it doesn't end there. It doesn't end because we deployed the application. We then go and analyze that even further. And there's some smoke tests that we can run to check if we pass in a JWT token that isn't valid. What happens? Are we allowed in? Are we not allowed in? And checking for those edge cases that we would expect to be handled. Bringing penetration testing in to the cycle as well. It doesn't need to be that one-off. We've done it, we've signed it off, that's it. It could be something that we perform on a fairly regular basis, just like things like scalability tests, performance and load tests as well. And then ultimately, that influences how we operate the system. Are there things that we need to monitor? Are there potential threats that we need to be watching for? And that concept of blameless postmortems that we talked about earlier, in terms of that growth mindset and really feeding that all back into the cycle. Security is not a gateway. Security is not a blocker. Security is something that we can absolutely bring in to our development lifecycle.
So last slide, just to recap for you. Depending on where you are in your developer velocity journey as a company, as a tech team, think about the actions that you can take. So the effective developer tool chain is, how do you share your code? How do you secure it? How do you do change control? The product management, how do you structure your teams? How do you make sure you can grow and learn as individuals and a team? So really foundational capabilities, but all of these help you go faster. So hopefully this has been useful. You have homework. I absolutely love giving people homework. So you can go take the developer velocity assessment. You can talk to your managers and really try and get things going. And we have time for questions. So hopefully I can sneak in a couple more areas we can ask. I can give you homework in.
Perfect. Yes, we have a couple of questions. Mark, do you want to do the first one?
Okay, so first question. Most projects are complicated from a development and architectural perspective due to a lack of adequate documentation available for onboarding. So in your opinion, how important is this for development velocity, or should developers simply be expected to follow and make development progress purely through reading code in source control?
Great question. Documentation is absolutely critical. So a big part of the drivers of developer velocity that McKinsey found, the standardization of planning, collaboration, and knowledge sharing was really important. So so multiple teams working on different things. Some folks might like the wiki, some folks might like Azure DevOps, some people put lots of comments in their code base. Standardizing on that so that you can point a developer or a data person to a single place and say, this is where you learn about what we have, helps speed everything up. Because whether it's the new person who needs to ramp up quickly or the person who's not been working on a project for 6 months and has to try and remember why the heck they made decisions. Writing it down in a consistent place is hugely valuable.
I agree. And the additional bit I'd add on to that as well, which slightly goes to the beginning of the question, was about kind of developers being productive from the very beginning. The documentation is one bit, and there's documentation about how the project or the application works, for example. But what about all of those tools and those frameworks and those dependencies that you need to get set up on your machine as well? To Steph's point about if you're the developer who's joining the project, or maybe you're switching from one project team to another project team internally. This world we're living in today with microservices, with different frameworks, different languages, different platforms, maybe even different clouds, there's no guarantee that the system, the machine that I'm working on is set up and tooled in the right way to make me productive straight away the moment I join that project. If you're lucky, the team have a great set of documentation where you can maybe get your machine set up in a day, maybe a week. If you're unlucky, longer. And that's where there are tools like GitHub Code Spaces, for example, now becoming available in the market, where you can go ahead, define what that development environment looks like in code, and get productive super quickly and easily as well. So I just wanted to add that bit in because I thought that was relevant to the first part of the question as well.
Next question. From what you've said, it sounds like you're suggesting that to automate everything is not the mantra we should follow, if there is little value from doing so. But isn't the whole point to ensure that test automation is made possible by doing this? Are you being able to give us a real world example of something or somewhere you wouldn't want to automate everything?
Mm-hmm.
So my rule of thumb is automate the boring but important.
Yes.
So it's important because it adds value. For instance, with doing unit tests, that adds value because it ensures quality and improves trust in what you build. So it's boring for me as somebody who likes making things to go through and do lots of testing every time I make a change. So it's boring to me, but it's really important to me. Whereas I might only set up my developer environment every 6 months, and I might only have new hires every few months. So actually, instead of automating that initial laptop setup, I could write a quick wiki with a series of links to where you go and get the software so that somebody can just on day one click on all the pieces to get the installs and do them manually, because it's boring, but it's not important, and it's also not high frequency.
And I think I'd add, it's not a binary answer either. It's something that's always going to be shifting and always going to be moving, because something we haven't really touched upon throughout all of this, but it's super critical, is this idea of working in this agile way. You're going to be able to continuously reprioritize, and that prioritization always comes from what is important for your customers, what is important for your end users effectively. So absolutely not saying don't automate. Automate is important, but don't just feel like, okay, I'm just going to start automating everything for the sake of it. Do it for the right reasons, like Steph mentioned. Unit tests, super critical. Yes, boring. Yes, none of us like writing unit tests. We all like writing new functionality and new code because that's what's fun. But ultimately, if we want to maintain that velocity and maintain that momentum whilst not compromising on quality, then actually that is something which is important for our end users. Because otherwise they start complaining to us on Twitter, they've wrote down our app in the App Store. So actually that is something really tangible and important. So there's no kind of 1 or 0 answer to this. It's something that is really going to depend on the context of your project and where you are and what is important for your end users at that time.
Cool. So let's go to the next question. So in the past, we've tried measuring development and deployment velocity by monitoring things like the frequency of pull requests or the number of successful deployments from release pipelines. However, there wasn't really equality between the size of these commits and releases, since one might be just a small change and another could be a full feature. Do you have any tips for doing this?
It's a great question. I don't mean to be controversial, but the first thing I'd start with is the question of why. Like going back to the things that we were measuring and that objective key results and thinking about the metrics which are important. We always want to think about those end users. So those kind of number of pull requests, okay, I've done 100 pull requests this month, but so what? Whereas Steph has done 1 pull request, but has delivered something that our users have been shouting for the last 12 months. Which one is more important? I think is really clear. It's the second one, right? Because that is the more impactful piece to the project. So, from that perspective and that angle, it's kind of taking the next layer and going down the so what route of that and trying to understand what is the importance of the thing that we're measuring there, I would say.
Great.
I don't know if there's anything you wanted to add, Steph, on that.
Just that, to the point about like lots of 100, maybe 50, or even quite large pull requests versus one that has impact, the impact that you'd be having can start a little bit earlier in the process. So when you're thinking about feature requests and prioritizing what gets done, when you do work, you tag and kind of measure again, you align to what you were fixing or what you were building. And so when it goes into production, if you start doing things like observability and kind of tracking impact in your code and how it's used, you can then say, Steph delivered, in 3 weeks, this feature, which then made us X amount of cash. Chris delivered a new feature every day and delivered this amount of value. So you can start turning it around from volume to impact by aligning how you do the first stage, which is thinking about what should be done.
And that's where things like traceability come in. Your work items or issues or whatever tool you're using for that, and making sure you've got that mapping in terms of your commits, your pull requests, and being able to track back fundamentally that value.
Fantastic.
So I have a kind of a real life question. We had a bug in a project I'm sitting on today, and I fixed the bug and did a pull request. So pull requests are the enemy of developer velocity pretty much, because they are a manual quality gate needing peer review in our case. And since the entire rest of the team was on a meeting for 2 hours, I was sitting doing nothing with this. So what do you feel about self-approved pull requests?
Oh, interesting question. Steph, do you want to start?
I think you raise a great point. So one of the areas that that you've identified is partly the difference between feature requests and bugs. So features can be, and that new addition of value can, to a certain extent, be added at any time. But when you're dealing with bugs and customer blocking pieces, actually your process should probably be different. So you might want to start thinking about, yes, whether self-approval is okay in those circumstances, or whether maybe it is, but you have to have a much more enhanced testing suite, automated and run before you can do that. Or maybe have like an extra person who's outside of kind of the main dev team who can also do approvals. I think the answer might be the classic consultant, it depends, but definitely split out your process to feature requests and bugs to determine how best to handle those appropriately.
I agree. I think that balance of having the automation as part of the pull request. So have you got that build? Have you got those unit tests and smoke tests that pass to give you that sanity check? Because again, thinking of it forward for a sec, let's play out that scenario. I'm always devil's advocate. I like playing out scenarios. What happens if someone does approve that bug, which goes through that kind of fast path, let's say, so there's no manual approval, but something goes wrong, something happens in production? This is where that growth mindset piece is super, super important, because in that scenario, you're trying to do the right thing. You're trying to fix this critical bug, but maybe something goes wrong. Maybe something exacerbates a problem. The important thing there is that's not your fault at that point. That is a lack in the automated test suite to pick up whatever change happened there. So that's where then you go through that kind of blameless post-mortem perspective and understand, okay, what check did we not have in place that could have prevented this from happening? And how do we get that back into our test suite to make sure that thing doesn't happen again? And that's the important bit, is the learning aspect from that. So I think, to echo what Steph said, there's the it depends answer, but I think there's also an element of the growth mindset and the learning part as well.
Yeah, and I realize you can also advance how you do deployment. So you could use pull requests and things still for peer review, the automation, and having that gated quality, but you can also take a deploy it to live and see perspective once you reach a certain level of maturity around how you've instrumented your code and how you manage your infrastructure. So you can do a progressive rollout. So you can start with, first of all, you fix the bug, it deploys, but it deploys what's called a canary deployment, where it only goes to a certain amount of people. It checks whether actually this gets like fewer 400 or 500 errors in production. And if that actually improves quality, it starts rolling it out to more and more people. That is a really great solution when you have high developer velocity. Helps you get there, but it requires a lot of trust and a high degree of observability.
Just to add in on that, that's actually how a lot of Microsoft teams do that. So think of Windows as an example. Windows is obviously an operating system that is used by millions of people across the world. Are only production deployments. They are only ringed deployments, these canaries. And the first ring is the Windows engineering team. So if they get bad builds, if they get bad quality, they're the ones who feel that pain first. Same with Azure DevOps. Azure DevOps, there is a Azure DevOps organization at Microsoft called MSEng, MSEng, like Microsoft Engineering. That organization is part of what they call Ring Zero. So as soon as a release goes out, the first deployment that goes to is Microsoft Engineering. And then it will start going to some of those external Azure DevOps regions or deployments then. So if there are any issues, the teams to feel them first are going to be the internal Microsoft teams.
Cool. Some suggestions, some things to think about when we decide. So thanks to everybody for joining, and a big thanks to Chris and Steph.
Thank you so much for having us. It's been great to be presenting on Star Wars Day. May the 4th be with you.